This is a video showing a 7-segment display using a BCD converter through the Nucleo 64 board, the STM32. So it uses a 7-segment display. Each input is fueled by a 220 ohm resistor, which is then input from the board, which provides a ground to each one of the segment pieces. From here, we're going to have the BCD input, which this is going to be each one of these dip switches is going to show a 0 or a 1. If the first one's flipped up, that's going to be a binary code of 0001. If the second one's flipped up, 0010, which is going to be a binary 2, and so forth. So for this program, we have a flow chart that's shown right here. And the BCD converter, we're going to initialize. We're going to input the data from the BCD pins from the dip switches, PC8 through PC11. Going to take that value, we're going to logically shift it right 8 bits. Going to mask the additional 4 least significant bits, and then we're going to utilize a lookup table to then output the BCD value and convert it to an ASCII value, which is then going to be an input on PC0 through PC7, which is going to provide a ground for the common anode 7-segment display. Going to the code, we have the main part of the code. We're going to start up the internal clock, the GPIO-C mode registers, and then we're going to initialize those to 0, put in the actual proper codes for 5s, and then initialize the internal pull-up resistors. For that, we have a simple array which is going to be utilized as a lookup table, which is going to have the code values from 0 to 9, and then A, B, C, D, E, and F. The tildes here are going to utilize this as a traditional ASCII value for these digits for the segment display. And then it's going to use the NOT, since this is a common anode versus a common cathode. It's going to take this value from the input data registers, which is going to be the dip switches that are going to be flipped. It's going to logically shift them right, and then it's going to AND them with 0F to mask the additional bits. It's going to take that value from the array and then put it in the output data registers, which is then going to input it onto the 7-segment display. So for here's the functional test. We have a 0 because all the dip switches are in the down position. From there, we're going to flip up the first one, which gives us 1. In order to get 2, we're going to flip up just the second one. So we got 2. In order to get 3, we'll push up the far right one. And then to do 4, go back to 0, and then hit just the third switch. In order to get 5, you're going to hit up far right one as well, not the second one as well. In order to get 6, you're going to put this one back down, and then that one there. 7, you're going to add another 1. In order to get 8, you're going to flip the far left one by itself, which gives you 8. To get 9, flip up the far right one as well. 10, you're going to go back down to 8, flip up second one, which is going to be B. And then you're going to go to C, which is far right one up as well. So we got 9. You just get this here. So that's A, then B, and C, D, E, then F. And that's going to be the functional 7-segment display with the binary coded decimal input using a 4-piece dip switch.